Hello everyone and welcome to McLean 360. So in this video I want to solve a question on gear trains. This question is very much simple and straightforward. So let's get started. Right, so the first thing that you need to understand is that whenever you have a gear train, most of the questions will be asking for what we call the speed ratio. All right, this question is just arrangement of gears, and if you look at it, you can see that gear 2 is meshing gear 3 at this contact here, and then gear 3 and gear 4 are connected to the same shaft. Okay, that's why you can see that they are connected to the same shaft. And then gear 4 is meshing gear 5. Okay, and then you can see that gear 5 is meshing gear 6, right? And then you can see that gear 6 and gear 7 are also on the same shaft. Okay, and then there is gear 8. So essentially, if you look at the flow, it's basically gear 2, which is meshing gear 3. Okay, and then you can see that gear 3 is the same as gear 4 because they are on the same shaft. Okay, and then gear 5, gear 4 is meshing gear 5. Okay, and then you can see that gear 5 is meshing gear 6, and then gear 6 is the same as gear 7 in terms of speed because they are on the same shaft. And then finally gear 7 is meshing gear 8. So this is actually what is going on. If you are able to do this, then it means you've been able to solve the problem, right? Now in terms of gear design, there is what we call the gear ratio. Okay, so when we say the gear ratio, basically the gear ratio is nothing but the driving speed. Okay, so the gear ratio is the driving speed divided by the driven speed. Okay, but then in terms of the number of teeth, the gear ratio can be expressed as the number of teeth, so the number of teeth on driven. Okay, so the number of teeth on driven divided by the number of teeth on driving. So essentially, when it comes to gear ratio, the number of teeth sort of is like inverse. Okay, so let's go straight away. This question said we should find the speed and the rotation of the gear 8, but we can't just go to gear 8. We need to start from all the way from gear 2 and then move towards gear 8. Okay, so you will have to write the gear ratio in terms of gear 2 and gear 3. As a matter of fact, gear 2 is driving gear 3. So in terms of driving speed, it is supposed to be N2 over N3, which is actually the same, but then in terms of number of teeth is going to be the inverse. Okay, but since we are looking for the speed of 3, we just have to make it this way, and then it becomes like this. That's all. So it means that the shaft, so N3 is going to be T2 divided by T3 multiplied by what? N2. Okay, and that's basically very simple. We know that N3 is nothing but what? So the number of teeth on the second gear is 18, and that on the third gear is 44, or gear 2 and gear 3. So 18 over 44 multiplied by what we have here, which is basically N2. The speed of N2 is 1200, and the direction is basically counterclockwise. Okay, so counterclockwise, but it's a choice. You can say that all counterclockwise is negative and clockwise is positive. In that way, whatever you are doing, if you have a direction, then you get it, you can assign it in that sense. So if we assume that clockwise is positive, then we can say that N2 will be negative. Okay, in that sense, we can basically go ahead and say that since the speed is counterclockwise, is going to be negative. That's all. So we have the speed here. What is this value here? Let's all pick our calculators and do this together. So if you pick your calculator, it's going to be simple. That's 18 divided by 44 multiplied by 1200, and that's nothing but 490.91. So we've got 490.91. So minus 490.91 RPM. And that's basically the speed of the shaft 3. Now, interestingly, shaft 3 and 4, gear 3 and gear 4, they are connected to the same shaft. So it's like 3 and 4 will see the same speed, right? It's like you and someone, you are in the same vehicle, you're in the same car. So when the car begins to move, you all see the same speed. Yeah. So that's essentially what's going on. So we can basically say that N3 must be the same as N4. And so that is it. And that speed is 49.91 RPM. And then the direction is actually counterclockwise because it's negative. Okay. So yeah, so that is it. Now we have to look at the other directions. So if we look at the third one, if you look at 5, so let's engage. So we will pick 2 gears and engage them. So let's engage 4 and 5. Okay. So now we have 4. So let's find 5. So we can see that N5 divided by N4 will be what? T4 divided by T5. That's all. So that's going to be, so N5 is going to be T4 over T5 multiplied by N4. What is T4? So T4 is basically, T4 is 15, okay? And then T5 is 33. So 15 on 33 multiplied by 490.91. And that's essentially, so if we pick our calculators, we've got 15 divided by 33. This is multiplying 490.91. So that is 223.14. 223.14. 223.14 in terms of RPM. So basically, that's sort of the speed over there for you. Okay. Okay, so I think I have to clarify this. So if you go back, you can see that the actual gear ratio, the actual gear 2 was moving in counterclockwise. But if it meshes with gear 3, it's going to change the direction of gear 3. So if we assume that, so let's say that we assume that clockwise is, so let's say, okay, let's assume that counterclockwise is positive. Okay, let's assume that counterclockwise is positive. In that sense, since this gear is going to change, that's why we have a negative here. Okay, so the negative sign is just saying that we are assuming counterclockwise to be positive. However, this gear is going to end up clockwise. Okay, because if this moves in the counterclockwise, it's going to force 3 to move in the clockwise. Essentially, if 4 moves, so 3 and 4 will move the same way. So it means that if 3 is moving in clockwise, then it's going to force this to move, it's going to force, so 4 is actually meshing 5. So 4 is meshing 5, meaning 4 moves in that direction, and then it forces 5 to move again in that direction. So actually, we are expecting 5 to come back. Okay, right? Because if you look at what we got here for the negative, so actually this answer here is telling us that this is going to be negative. So I think it's supposed to be clockwise. Okay, this one is supposed to be clockwise, and then this one will go back. So the fifth one will go back and become counterclockwise. Okay, so that's what happened. Whenever 2 gears meshes, there will be a change in direction. So essentially, if 5 meshes with 6, because 5 is moving this way, it's going to force 6 to move that way. Okay, so let's do that for 6. So let's do that for 6. So N6, so N6 and then 5. So 6 divided by 5 should be equal to 5 divided by 6. So that we can say that 6 is going to be 5 divided by 6 multiplied by 5. So T5 is so what is T5? So yeah, T5 is nothing but so T5 is 18, sorry, T5 is 33, T5 is 33, and then T6 is 36. Okay, T6 is 36. So that's it. T6 is 36. And then you multiply this by N5. So N5 is nothing but 223.14. We just solve for it. All right. So N6 is going to be so 33 divided by 36 multiplied by 223.14, and that's 204.5, or let's say 55. So 204.55 RPM. But you realize that this 6th gear will be moving in the clockwise direction, so that's going to be negative. Okay, but you can just say that it's clockwise. Okay, don't be confused about the signs. It's just telling us that it's going to be negative or clockwise. That's all. Now we are done with the 6th gear. You realize that gear 6 and gear 7 are on the same shaft. So it means that 6 and 7 will feel the same speed. So in other words, 6 is equal to 7 is equal to 204.55 RPM. Now we are done with 7. Now this is where we are. In fact, we are at exactly where we are supposed to be, which is the 8. And that's essentially what we were asked to find. So if you look at the 8th gear, N8, N7 is nothing but T7, T8. And that's essentially, so N8 is going to be T7 divided by T8 multiplied by N7. Essentially, when you get to this part, you know everything. You just substitute. So T7 is 16T. Okay, T7 is 16T. T8 is 48. So essentially, that's 1648 multiplied by 204.55. Okay, 204.55. So that's going to be, so 1648 multiplied by 204.55. 68 point, so let's say 68.18. So 68.18 RPM. But you realize that if you mesh, so 6 and 7 is going to move in this way. It's going to force 7 to come back. Okay, so essentially 8 will be going in counterclockwise. Actually, just going to be positive. So you can either bring negative here and negate this, or you can just leave it like this, and then you can say counterclockwise, because that's essentially what happens. So this question has been solved. The speed of the gear 8 is 68.18, and then it's moving in the counterclockwise direction. So this problem has been solved. The question said we should calculate the speed ratio. Okay, so when we say the speed ratio in terms of the gear trains, that's nothing but the driving over the driven, which is given by so the first driving is the second, which is 1200. So 1200 all divided by the last gear, which is 68.18, and that's essentially so 1200 divided by 68.18, 17.6. So 17.6. So that's essentially telling us that if we have been able to connect these gears, then we have been able to amplify the gear power by a factor of 18. Think about using 68 to get 1200, and that's the power of gear trains. Thank you very much for watching.